Hello, in this video we will talk about binomial and hypergeometric distributions probability calculation because we feel many new learners for statistics feel these two probability distribution a little bit confused. So we just use this plot to show the trial for either with replacement or without replacement. So if the trial for each take out each element and put it back, this is the old population. For example, there are 10 boxes for the red and the blue. So here we have total red box 6 and the blue box 4. And we take out 5 samples. If we take one by one and put it back before we check the next one, so this is called the replacement trial. And if we take out one and not replace back, then this is not a replacement trial. So for the replacement trial, this is the Bernoulli trial, and this is and the red, for example, we think red box is the success. So here the success number follows a binomial distribution. But if we use without replacement trial, so the red number follows hypergeometric distribution. So very clear. The trial is similar, but one is replacement and one without replacement. So one is binomial and one is hypergeometric. So now we say the binomial distribution. So if they are independent trial, if we take, for example, 5 trial from the last figure, so this is independent because the trial is replacement. So this is same as before for each trial, right? We will get the constant probability with pi for the success. So because we do not change this population from each child. So there are constant number red box in the population. So the probability for each child is the same. Although the sample can be different, right? No matter this is the replacement or without replacement, each child can have different red number, a blue box. But if we take a very, very large number, for example, 10,000 child, so each child has 5, we take out 5 elements, 5 books. So we take such trial and experiment 100,000 times, then it will be very close to the probability with red frequency, and the blue ball frequency will be very close to the population's probability, right? So now how to calculate the probability for binomial or hypergeometric distribution. So for the binomial case, we also think the red box is the success number. So the success numbers is a random number, right? Random number. But we need not to try 100,000 times to count the frequencies. We can just use the formula. But before we understanding this formula, this is the formula for calculating the binomial distribution success number. So here is a combination from n, y. So n is the sample number. So we get 5 here, right? But the y is the success is the red box number. And the pi is the constant probability for each child. This is the proportion of the red ball in the population. So here we have 10 red ball, 10 ball, but 6 are red, so the pi is 0.6. So 1 minus pi is 0.4 for the blue ball's constant probability. So very clear, if we have y red in the sample, so y will be on the power of this pi. So n minus y will be on the power of 1 minus pi, right? So for example, if pi is 0.6 and y will be 3, So n is 5. So we can calculate the probability for 3 variable is combination of ny times 0.6, and y is 3 here. So 1 minus pi is 0.4 here. Then the power is 2 because 5 minus 3 is 2, right? But why we use this combination here? So combination's calculation is n factorial. So factorial means 1 times 2 times 3 times 4 until times n. So this is n factorial and divided by y factorial times n minus y factorial. So why we use this combination here? We look back. Because this sample, so we also take 100,000 sample, right? So this sample has 3 red ball, 2 blue ball. And next one is red 2, blue 3. Next one, red 4, blue 1. And red 1, blue 4. And again, red 3, blue 2. So because we do not care which red position or which blue position, we just care how many red ball, how many blue ball in the sample, right? So which means there if we take 5 ball, there in total how many different ways? Because we do not care about which position for the red ball, blue ball. We only care about how many numbers, right? So how many ways? This is same as to say we take 5 ball and no matter which 3 ball, red ball will be placed, we only care about 3 red ball. So this is the combination of 5, 3, right? These are many different sample, but they have all 3 red ball in total from 5 ball. So they may occur right here, but how many ways? This is a combination of 5, 3. So this is why we times this here. But for each one of them, the probability is 0.6, 3 in power times 1 minus 0.6, 2 in the power. So this is the binomial distribution's random number probability. And for the hypergeometric distribution, this is not independent because this is non-replacement trial, and the success probability is not constant. Because if we take out the first ball is red, there are only 9 balls left. So the probability is changed for both a blue ball and red ball in the next trial. If we take out next blue ball, the probability also be changed. So each time the probability not independent from the first trial. They are constant. They are conditional probability based on last trial, right? But the sample can also be like this 3 ball, 2 red ball, 2 red, 3 blue. And also we do not care about the position. So this is the same as in binomial distribution. We do not care. We only care about how many red ball, how many success. So how to calculate the probability of hypergeometric distribution for the red ball? So if you take 100,000 times, they will also have samples with constant, for example, 3 red ball, 2 blue ball, or 2 red ball, 3 blue ball. They have the different position because we do not care about this position. So this is the idea of the combination. So combination, the total how many ways of taking 5 ball from 10 ball. So this is the combination of 10, 5. So this is the total ways of taking 5 balls from 10 balls. So this is why in the denominator is n. So this n is the population, here is 10. And this is the sample number is 5, right? But in numerator, there are 2 part projection. So one part is the red ball, total red ball. We take 3 here, because if we want to know the probability of 3 red ball of this hypergeometric distribution. So this is the 5-3 combination times, sorry, this is 6-3, because there's total 6 red ball in the population, times 4-2, right? Because there are 4 blue ball in the population and 2 blue ball in the sample. They are total in these ways. But this way, this how many ways? Of course, is less than this one, because this is the total all the 100,000 samples. But we only get a part of these 100,000 samples which have 3 red ball, right? Because other samples have 2 red ball, 1 red ball, 4 red ball. So this is only the how many numbers, how many different ways of getting 3 red ball, 2 blue ball. So this is the 2 combinations projected together. And this is how many total ways of getting 5 ball from population 10 ball. If we do not care about it, this actually include all the cases of different ways of red ball, blue ball combination. So we just use combination of 10, 5 here. And this is only the case for how many ways of getting 3 red ball and 2 blue ball. So we make the division of this part 2, then we get to the probability of red ball 3 in this case. Sorry, this is the hypergeometric distribution, not a binomial, right? Hypergeometric. This should be hypergeometric here. So we, in this video, just explain the calculation of binomial and hypergeometric random variables probability. Thanks for watching.